Welcome to Network Automation Heroes, where we speak to the movers and shakers in the network automation scene to find out what they're up to. This week, however, we're speaking to somebody who's not in the network automation scene. Jeffrey, welcome.
Thanks, Mark. Good to be here.
So one of the themes that I've been looking at to focus on in these episodes recently is it's kind of code words standing on the shoulders of giants, but what it really means is we're doing a lot of stuff in the network automation movement right now, which other parts of the technology world have maybe invented or maybe not invented, but used before. And one of those that comes up very often is roughly referred to as like continuous integration or continuous integration and continuous delivery. And what we want to do here, and this is for everyone watching at home, is speak to Jeffrey, who's had a long and varied history with some of those technologies, to really try and get a sense of how did it come about? How did people think about it then? Maybe how do they think about it now? What problem does it solve? So Jeffrey, maybe I can ask you first to just give us like a quick intro, kind of who are you, where are you, and then we'll go and do a history lesson.
All right. So, Jeffrey Fredrick. I usually describe myself a bit differently depending on what context I'm in. So I might say currently I'm a VP of engineering 4 days a week, and one day I do consulting and coaching for executives and executive teams. I got here through working at a lot of different startups. I'm currently based in Santa Cruz, born in Silicon Valley, which is that's a very fortuitous event, a good right place, right time. And throughout my career, I've done pretty much most of the jobs you can do within a software company. So I started in technical support. I've done QA. I've done development as a developer. I've been a manager. I've done time in marketing as a product manager. I've helped with sales calls. I've been an evangelist out on the road, talking to people, usually about development tools, and a member of various executive teams over time. So I worked at a lot of different companies, mostly small, but currently at the largest company I've ever worked at. Where people know me in the world, and some people out there know me, they might know me as an author in the IT revolution stable. I work with a co-author. We wrote a book called Agile Conversations, which is about cultural change through doing conversation analysis. Change your conversations and you change your culture. With the same co-author, I'm a co-host of the Troubleshooting Agile podcast. Actually just finished running a meetup for 10 years on conversational analysis. Decided I wanted to take a bit of a break from that, but some people know me. Also, I've been a co-organizer of a long-running free open space meetup that will happen soon called CITCON. It was originally the Continuous Integration and Testing Conference, very relevant to the topic today. We started that in 2006, co-organizers PJ and Paul Julius. And he and I have really watched the continuous integration movement spread from something, a very novel practice. PJ actually was the founder of the first very popular open source CI tool called Cruise Control. He started that project in 2001 when it was covered by Martin Fowler in his blog back in 2001. That was when a lot of people first heard the phrase continuous integration. And we've kind of watched as this idea of continuous integration as around a development step spread increasingly what we call end-to-end and touching every part of the software stack. So probably it was, could this software build? And then it became, can we run tests on it? Can we run acceptance tests? Can we start deploying? And so you see things that we used to be called end-to-end continuous integration become things like DevOps or DevSecOps or any number of other things as people sort of say, oh, it's really valuable to make sure all of our stuff works together. So that's been an ongoing trend and still continues.
Great intro. Thanks, Jeff. I think a lot of people watching this will be from the network engineering or network automation sort of space. And they will probably have heard about continuous integration, testing, and all this kind of stuff. I want to leave networking and network automation kind of for later in the call for now, and go all the way back in time to PJ was involved in writing this first CI server. You were certainly very early in being involved in that and sort of
Yeah.
understanding that. Maybe you could paint the picture of how software engineering felt to you just before that moment. Like what was
Sure.
happening then, and kind of what was the catalyst for doing things like this?
Sure. And I would say for me, the idea of continuous integration is something that I was introduced to before the first CI tool, and
Mm.
and and kind of in two different ways. First was the phrase continuous integration, and that term actually wasn't related to tooling at all. It was related to a practice in extreme programming. Um, and this was an insight from Kent Beck, who developed extreme programming. He said, like, if something is hard, we should do it more often. And in the 90s, because that's where the gray beard comes from, I am that old. In the 90s, um, there was a phase that I like to call documentation driven development. The idea if we just write everything down ahead of time, then nothing could possibly go wrong. And you had, when people hear waterfall, I don't think they can really understand viscerally what it was like. But a normal project would be 18 months. Like that would be not even a particularly large project. Projects might be multiple years before anything was delivered, and things really did proceed by phases. And there would be in the project plan an integration phase, and what that meant was it was like the first time that they actually tried to get all the software to work together. And that was just crazy. And so what happens is you had many projects that would go a year before they try to make the software work together. And then the integration phase would be on the calendar for 3 months or something. And then it would be 6 months, and then it'd be 9 months. And then the project would be canceled because they could just literally could never make the software all work together. And so you get the very opposite approach, this reaction coming out from a bunch of people who went through these giant failed projects. Um, I mean, for people who are history nerds, you can look up something like the chaos report from the Standish Group talked about the rate of software failures, just massive. And so many projects like this died. And so they said, well, what if we did things differently? What if instead of going 9 months without really making our code work together, what if we made sure it worked together all the time? And by work together, I mean, at the barest level, it meant compile. Like,
Hmm.
does our software compile together? And today this seems crazy, but literally my first job, I was at a software company called Borland. Some of the older people remember Borland back when it was like the Google of its day in the 90s. It was a sexy place to work. But I was in support on Loan to QA on our new IDE, and being support in languages in C++, I wanted to go build the IDE. Let's see what it looks like. And I tried running, I got this code and I couldn't run it. And I thought, wow, that's weird. It just seemed weird to me that I couldn't compile the software of the IDE product that we're building. So I went to the developer who had done the last check-in. I said, hey, I tried pulling the code and I noticed it doesn't compile. And he looked at me like I was a moron, go like, of course it doesn't compile. I'm still writing it. And I was like, oh, okay, sorry. Never had occurred to me that you would break the editor, break the whole product for everyone and be like, yeah, that's fine. Of course I break the product. That so that was just the way the world was in the 90s. People literally didn't expect the code to even compile day to day, let alone work. And then you had these continuous integration people come along on the process side that say, no, we should make sure our code compiles before we commit it. It should always build. In fact, it should always run. And so we'll have a practice of like, before we commit, we'll pull all the code, make sure it runs, and then commit. And there'll be a dedicated check-in machine for it. And maybe you'll have some a hardware tool. And my favorite one is a rubber chicken. James Shore, when he heard about when cruise control, when he was reacting to cruise control, he's like, CI is not about a tool. Like you don't need software for it. You can have a rubber chicken, which is the chicken was their check-in token to be like, I am currently integrating. Anyway, that's the practice side I came to. I do want to touch on though another thing, which is the tooling side, and that really for me goes back to Netscape in the 90s again. They were started off as the dominant browser, the first commercial browser, and then they are migrating. Now, one of the things they did is they covered lots of different hardware and software platforms that people would never think of today, and not in Java, like in C code or C++ code. So they need to be compiling on not just Windows and Mac and Linux, but HPUX and SGI and da da da. And they had a matrix of like 13 or 18 different hardware software platforms they supported. And the challenge was, how do we know that our code, I as a developer can be diligent and make sure it compiles for me, but given the nature of C++, how do I know it's going to compile on all these other platforms? So they
Right. Without
developed a bit of,
testing it manually
yeah,
12 times for each
I
platform.
don't
For
I
yeah.
don't, and just physically, like I don't have a set of 8 different Unix workstations, each of which costs $15,000 under my desk to go try it.
Mhm.
Like I literally do not have access to the hardware, and it's hard even for the office to do it. So what do we do? And so they created this tool called Tinderbox, and Tinderbox was just something that all it did was ran in a loop and pull the latest code and compile. And if the compile failed, it would notify the people who'd checked in since the last passing build. That's it. And that, in a sense, from my experience, that was like it wasn't called that. It was like but it was like the continuous integration tool that could at least tell you that main is passing everywhere, it's compiling or whatever you want to do. And that's the thing is that, as I said, what we want to check these days has grown from the basics of does it compile to does it all function correctly? Does it pass our security scans? Um, can we deploy it? And when you get into networking, I think it's still relevant is will it work on the topology that we're deploying to? Even if it's not literally the production environment, can we have a similar topology and know that everything talks to each other and we have all of our rules worked out and everything else?
I started my software career a little bit after you. I mean, I started coding certainly in the late 90s, but I was working on my own. It
Yeah.
was early 2000s before I sort of worked with others. And
Yeah.
I still got to see some of this. And one of the things that you beautifully described, but I just want to like make a little bit more explicit, is this point about the integration cycles or integration phases.
Yeah.
Because in my experience, it wasn't actually that like all the people who wrote the code were sat in a room together figuring out how to integrate it. What I
Right.
saw is that the people who wrote it were now doing something else, and other people were now trying to figure out how to integrate their code. And I think this
Yeah.
relates to one of the core problems that people talk about with the waterfall approach, which is not only do we wait too long for feedback, but often the people who are the source of the input are now gone and doing something else.
Yes. Yeah, very much so. And even we're saying sitting in a room, like in the 90s, I mean, the caste hierarchy in software didn't work that way. The layout of the offices at Borland might tell you this is a 3-story campus. Developers had private offices on the 3rd floor. Testers and documentation people were on the 2nd floor, and salespeople and marketing and support were on the ground floor. So if you were someone who was trying to debug a problem and you're in testing, you literally had to go up to a different floor and knock on a door and say, I'm really sorry. Because remember, there wasn't even like ubiquitous email at the time. Um, so the divides between people were much greater, and it very much was, as you say, like there's a handoff phase where, okay, now it's those people. And it's like their job to get it working. And I've come across, and we say this like this is the 90s, but I'll say I've come across banks a decade or two later after that, in the late 2000s and early 2010s, where I visited them and they were describing that they have a team that develops the software. And then when it's done, it's given to the other team who operates the software, and it's their job to make it work in production. And any problems with making it work in production, that's simply a different group. So really, it's exactly what you're saying today. The integration phase for a lot of people in production, making it actually function in production, keeping it functioning, totally a different set of people. And good luck to them.
It's you pointed that out in such a way that I want to kind of what I'm going to do is plant a few seeds that we can come back to later. And you just mentioned this idea of having one team do something and then pass it to another team.
Yeah,
And this is something that's going to come up a lot. Now, specifically here related to continuous integration, it would be the developers and the testers, for example.
yeah,
But then you also mentioned deployment, which would be developers and ops. And I think we should circle back to that. Before we get there, though, I want to kind of just make this maybe more abstract or maybe more basic. Because, on the one end, we've got software projects were failing.
yeah,
And on the other end, we've got if it hurts, do it more often.
yeah,
And I feel like there's kind of a fundamental something happening here, right? And what I like to what I always say is that the cost of finding out that you were wrong about something
yeah.
increases exponentially with time.
Absolutely. Yeah.
And then the question is, would you like to pay more? Right? And typically people would not like to pay more. But
Yeah.
you've been around it much longer than me. Would you describe it like that? Or how do you kind of get across that sort of fundamental assumption here that goes into a lot of this catching things early?
Yeah, I think that's a great point, and that is definitely the motivation. And the idea that we would pay less to discover things early, that was a very old idea. When I went to my first sort of testing quality discussion, led by James Bach, people in testing might know him, at Borland in like 92, 93, right? The idea that the later, the longer it goes, the more things cost. And I've often told people this, and I make the analogy with something even like word processing. The difference between dictating something and getting back a draft and then redlining it and like having someone go retype it and bring it back, that kind of edit cycle. Or in the old days of punch cards, to do your punch cards and then put them in the machine and then have like, oh, there was a compiler error and you've now like lost your run for the night. But these days, what we have instead is I'm typing and the spell checker, comes up with a highlight, says, "Oh, this is wrong." Like this is, both in word processing, also our IDEs, right? We'll say, "Yeah, there's no variable named this. That function doesn't exist." This kind of rapid feedback seems so small, but it makes such a huge difference in productivity. And what I want to say about that is that it's a combination of tools and expectations. It's a socio-technical system that enables this change. Because before what you had was people saying, look, we need to catch problems earlier. So I want you to do a bunch of manual work, like check your code, like look at it really hard, try really hard. That's really what it was. But really not giving people the support to be effective at it. Because it's really hard to review your own code. In the same way, it's hard to find the mistakes in your own writing because you know what you meant, right? Yeah, I don't know how often I've gone back to an email and been like, what the heck? How did I have all these mistakes? This is not English. These are not words. But at the time, it read fluently because I knew in my head what I wanted. So then you had like a social practice of like, oh, we're going to review someone else's commit. At the time, they didn't, in the 90s, they didn't call them, it wasn't reviewing pull requests because we didn't have the technical part for that. But socially, you might do a code review of some kind. But one of the enablers then of people being able to take more responsibility is something actually very subtle that we actually even talked. The difference between the mid 90s and the late 90s, what allowed people to do it, is actually people writing build scripts, systematizing the way the thing was built, because it was very common in the 90s that there would be no build script and there would be a build engineer. It was a person's job to go collect all the artifacts and do something to then produce a binary that would be the thing that was then tested. And when that's the case, when essentially the people writing the code literally don't have the ability to create a working testable version of their software, there's limited diligence they can apply. There's limited diligence and discipline they can put into reviewing their own code. So that's what I just wanted to bring up about that, is that people saw the value of detecting things early, but there's a certain technical enablement you need to get the social practices that to really give you that payoff.
I'd love to use that socio-technical angle to maybe move a little bit towards networking for a moment. And I was in Iceland recently. I gave this talk about shifting left, and what I tried to do is paint this picture of upstream and downstream teams,
Yeah,
and it could be like let's paint out some examples. So like developers are upstream and they are creating code.
yeah,
And downstream, there is a testing team who are responsible for testing the code.
yep,
So, okay, that seems fairly easy. Then if we layer on like a couple of characteristics, the development team is incentivized to go faster. The testing team is incentivized for things to not break.
yes,
Another way of putting that is like if too many things break, the testers will get fired. And if not enough features like come out, the engineers will get fired, right? The
yeah,
software engineers will get fired. And this creates these like really interesting scenarios where because there are these tricky incentives, a couple of things happen. One is, and you touched on this earlier, for me, it's always like a canary in the coal mine if you start hearing a lot about the word discipline, like especially if you're pointing at another team.
oh yeah, yeah, yeah,
Like if those guys were just, X, Y, Z, then
yeah,
we wouldn't have any of these problems. And you know, in if for the downstream team, the instinct very often is to protect themselves. There are various names for this over time. I like to call it the comfort blanket. But it's like, right, if we cannot trust you to send us code or network configurations or whatever they're going to work. So we're going to have lengthy documents that you must read and go through
yeah,
and change control boards and other things that will force you to be disciplined
yeah.
so that we are safe, something like that.
Force is my keyword. The way discipline was for you. When I hear force, I'm like, uh-oh, there's something wrong in the dynamics here.
Right. And the same thing applies to DevOps. And I think we see it in networking teams today as well. Now,
Yes.
that's a little different because often inside the department of networking, you will be having both the upstream and the downstream there. But it's
Yeah.
definitely common to see change control boards and lengthy review processes in a lot of the ways, which are understandable in one sense. We want to mitigate risk of outages in the network. But I'm wondering if you could maybe like tie all of those together into what you've seen about, how those patterns emerge. And to your point earlier, where is the sort of like as the graph of cries for discipline raises to tends towards zero
Yeah.
to infinity, how tooling sometimes starts to help there.
Yeah, for sure. And so one way I could have used instead of discipline, because you're right, it tends to be like the other people need to be more disciplined. The word probably better would say like there needs to be certain enablement for people to really take ownership of
Hmm.
the quality of what they're doing. And so that I think has become the domain of like platform teams, is sort of like how are we going to provide tooling that will allow people to take ownership for what they're doing. Um, and what you said about the comfort blanket of we're going to be the people who say no, right? And that's like the um, what you're saying is if what really what they want to be able to say is like it's your fault. And one thing I just want to share because you said like the problem of incentives. The worst case is development teams who will like write in cases where people have done they write the feature, they'll have a button, but it doesn't work. Like the method is not there behind it, and it's like yeah, but the button's there, so we can say it's feature complete. It's just broken. Like honestly, so they can say that they've met their milestone. Like total garbage, right? This is where you start to hear discussions in the team of like, what does done mean, right? What we want to be done. We don't not just done, but done. Well, what does that mean? Like stuff actually works. It's like, oh, okay, and of course, then eventually get done. But back to the idea of the technology and what it enables, right? In my mind, the the if we have the tooling in place to enable people, it really does allow people to take ownership in a different way. And when I was first deploying cruise control within a company, so this is 2001, I went to go actually build a continuous integration system not knowing about cruise control, but I did go check to see what else was out there first, if there's an existing open source project, and I found it. And for me, what the problem I was looking most to solve is, that there would be a nightly, every night we do a build, and the build engineer would do a build, and it would be ready for QA to deploy in the morning. And if something went wrong with the build, well, then QA essentially lost a day. And it was, how could we not lose days? And what I wanted was, by putting cruise control in place to check for compiler errors and then later testing, what it changed socially was that people would do something like they would do a commit, and people say, "Oh, you want to go to lunch?" They're like, "Oh, just wait a minute. I'm waiting for the email to let me know that the build passed." Right?
Yeah. Well, I laugh because I remember this. Yeah.
Yeah, so this wasn't discipline. I think to your point,
Mhm.
this wasn't like people. It wasn't something that was imposed on people. But as soon as people could get that feedback, they wanted to be responsible, right? They didn't want to leave people in a lurch. But when they could when they could count on the fact that, oh, my commit, when it passes, it's going to give me an email, or if it fails, it will message me. And then, oh shit, here, you know what, guys, let me fix this. Or maybe they'll say like, oh, I can't join you for lunch, or let me fix this first. It'll be 5 minutes, and I'll just make sure the build is not broken, and then I'll join you for lunch. Total change of behavior, just done by giving people the information they would need to act responsibly. People, in my experience, don't. If you're thinking like, oh, they're lacking discipline, it's probably they're lacking the information and feedback. So that's one of the core dynamics I've seen in this, and the role then of tooling is making that easy for people to do, giving them proactively the feedback so that they can take ownership.
It's a really interesting way of looking at it. It's sort of the antidote to crying for discipline, which is give people give people the tools they need so that they can take more ownership, or so that they
Yeah,
don't have to have superhuman discipline to do the right
yeah,
thing.
that's right.
Um,
And can I just real quick, I'm gonna tie this to something that early in the days of Agile, what made Agile projects, one of the things that make them work is a coordination mechanism for people on progress and what they were doing. And there's a principle, and I really like it. It was described by Brian Merrick, who is one of the signatories of the Agile Manifesto. He also has a great podcast, by the way, called Oddly Influenced. Um, he he talked about what he called big visible charts, and there could be a number of different things, but the principle was, if you have a room with all the people in it and you put a big chart on the wall saying something like, here's the number of our feature points that are completed. This is our burn down chart. This is our number of defects, right? By putting up, you're kind of saying this is something that matters. In the world of CI, that became build radiators. Actually, we had at one company I worked at, we actually had a lava lamp. We had two lava lamps. We had a red one and a green one. Originally, we had just a red one. The problem is that people kind of like lava lamps, and we
just look.
they just like to have the lava lamp on and running. So if it's only running when it's broken, they're like, eh. So when we got a green lava lamp, suddenly it's like, that's cool. And that was like, oh, the build's broken. Let's protect the lamp. Like we don't want the red light. This is weird. We don't want the red light to go on long enough for the wax to get molten. Like if it starts bubbling, that's a sign that it's been broken for a few minutes. And so it was like a race. And this is even funnier. If you did get fully molten or got partially molten and then turned off, you'd get these kind of like wax castles. And people would be like, hey, that's a cool one. Let's make sure we don't leave the build broken long enough, right? So
Yeah, right.
right. So this is just a weird example, but the thing is about what it really is about people having these visible coordination mechanisms. And so it's not, I described earlier, email. The thing about email is it's often like just to point. It's not necessarily shared context. So part of this, if you want the right behavior, is how do we provide shared context, a big visible chart where it's clear to everyone what the current state is. And if there's a problem, hey, there's a problem. And then it falls on, they can start asking, hey, that's a problem. Is anyone working on that? Do we know what that is? Is it being resolved or not? When those discrepancies between what you expected and reality are being highlighted, people will act on it.
especially between the people in the team, because sometimes you will have different expectations versus
Absolutely.
an unknown reality, right? And this is where we see in the network automation space right now, everybody moving to a source of truth, right? So
Yeah.
Netbox is one, there are others, and there are
Yeah.
many areas in the moment from a network user asking for a change that would require a change to the network, or perhaps the network team itself is going to upgrade something. Somehow we're going to change the network.
Yeah.
And from the moment that we decide that all the way to the moment where the change is being made and the network is proved to be working, there are a lot
Yeah.
of areas where even within the network engineering department, we can be misaligned.
Yeah.
And the first one, and this is directly analogous to like GitHub for software engineers these days, is as network engineers, we put what we want the network to look like into, for example, Netbox, and
Yeah.
then we look at it together and we say, does that do we all agree that that captures what we think needs to change in the network in order to fulfill whatever this change request is? Obviously, moving down from there, then you get to what we were calling earlier, like CI/CD, where we may render network configurations and check those somehow. But again, I think the point you're making is that throughout that sort of life cycle, we're trying to
Mm.
make sure that anybody who can have an impact on the success of that is aware of the status of it.
Yeah. But even what you described there, even if it's people joint around looking at the same source of truth, the same facts, that's very much what the original continuous integration practice was, right? It
Mm-hmm.
was like, hey, I'm going to make a change. It's going to go into source control. Do we all look like this is the moment of integration? Are we looking at the diffs? Is it what we expect? That was the review process of continuous integration. Like, we're making this change. Is it what do we all agree that these facts are the future facts, the future state post commit is what we want? So it's really describing the manual process, people being taken ownership, and then you get the feedback of did things did things. This is statically what we expected, right? This is our explicit model of what we think should be right, and then later you have like, and then how did it actually operate in practice? And I think there's two steps there, and both are important. And I think a lot of people miss that with the continuous integration. They just think about it one side, but there's both. There's that sort of static, this is what we think the state should be, and then does it work? And those are different things. Because you can have like, yeah, it's the state we wanted, but the emergent properties.
In relation to what?
Exactly, and it doesn't, and it could be any number of things that make those emergent properties invalid. But even though it was exactly, yep, it's exactly what we designed, right?
I want to stick a pin in that and come back to it. And the reason why is because so your conference, or your PJ's conference, continuous integration and testing conf
Yeah.
originally. And very often we talk about continuous integration, which can include things like building stuff,
Oh,
and testing, which can
yeah.
also include things like deploying stuff together. And I think there's a through line there about kind of asserting things that we believe to be true. But before we go there, I want to maybe just finish up on the topic yeah, of the sort of socio-technical that you
Yeah.
began, which is to talk about how maybe how roles change during shifts like this. So, if we go to the sort of so your 90s example of having to walk to a different floor to speak to a developer,
Yeah.
we have very sort of specific roles doing specific things, perhaps the incentives are not aligned, etc. Over time, what I've seen with, for example, automated testing or later DevOps is you start to get these new role titles pop up. And I think sometimes what that is a reflection of is technology has emerged to help these previously disparate teams sort of function more holistically. But that technology itself is sort of an area of expertise, which now, um, spawns new industries, has new job titles.
Yeah.
Network automation expert, DevOps engineer, all this kind of stuff. Can you talk about your experience of seeing how that's kind of moved the job market around, the job titles, where people focus their
Yeah.
time?
Yeah. It's funny, although I mean what I'm gonna say is like I think sometimes those at least some of those job titles I think were evidence of a misunderstanding, right? um, like I'll just start with DevOps is the easiest one, right? Patrick Dubois, who coined the term DevOps and started DevOps Days, which kind of started the movement. He came to CITCON in 2008 and then started DevOps Days in 2009. So we were talking about the same practices in the world of like end-to-end continuous integration, including, because we looked at it as like, it's not just developers and testers, it's also sysadmins and everyone else involved in that sort of value stream. The whole point was this is dev and ops collaborating. It's not handing over from a dev team to a DevOps team to an ops team, right? Wait, what are you doing? What are you doing? And the whole point was you rather than having the project move between teams, you took people to the work to collaborate. And that was very different. So that's one thing that happens is I think certainly when these practices originate, they often originate off of what you might say in other places, cross-disciplinary studies, which is the term in academia, when you bring people who are physicists with people who are biologists or something, or chemists, and you get these cross-discipline experts and they come together to have insights that they wouldn't have on their own. And sometimes it's because they bring a different mindset, different knowledge base, and also different practices. And it's the practices I want to focus on, because the other thing that's happened throughout this, and the reason I brought up the point about the build engineer as a person to becoming a build script is there's been a huge change in like establishing standards and standards of practice and what's expected. And generally speaking, the way I look at it, I've seen over the 90s is a move from what would have been pre-assembly line manufacturing. Anyone who's read like lean manufacturing book, and contrast that with how cars were made before assembly lines and before, like you contrast that with Toyota and how everything's standardized. That ability to it's such a powerful unlock to go from like each person with the same job title. This is my point, with the same job title, working differently, right? The way that people would work from one shop to another would be entirely different because it was essentially like an apprentice system. You learned from the master how to work, and then that was the way you were a journeyman. You might come up with a couple more techniques, but you basically were limited by the personal exposure and experience that you had, and you came up with bespoke techniques. In my view, that was something that I saw in software. I saw it in building, build scripts. I saw it in QA. I saw it in operations people and sysadmins, and I've seen it in network engineers, right? What the practices are from a networking team or DB admin or any of these roles was kind of entirely up for grabs, right? There wasn't really a sense of how things were going to be systematized and what standard practices were. The standard practices, or to the extent there were one, were very fuzzy and loose. There really weren't, I would say, very well-defined best practices. You might have something like RUP, the Rational Unified Process, and it would say some things, but the way that was actually implemented, if you went from site to site, was very, very different. I had that experience of seeing different people who were reading the same book and then doing very, very different things. So one thing that's happened in the 2000s is people know much more about the way software is done in other places, and they've learned a lot more about what expectations could be, especially among the top percent, the ones that get talked about the most. And there's definitely a gap between these sort of top companies that originate these practices and write up and share their experiences and what people find in their day-to-day. They'll use some version of it. And in their attempt to do something like it is where I think you then get the creation of new titles like DevOps engineer, because it shows people trying to say, how do we get to those practices? But what matters, and what often is missed, is the dynamics between the people. It goes back to there's an attempt. This is an organizational failing. They try. I say this. I'm using the phrase before, the contrast between statics and dynamics. A lot of people, they look at organizations, how they function through a static lens of org charts. And that's not what matters. What matters is the dynamics between people. And the creation of new job titles is often trying to provide a static fix to try to get the right dynamics. Might work, might not, but it's very hit or miss. But that's my thought about where the new job titles come from, and I'm curious what you think. I mean, I could say like I'll say one thing that like the rise of something like it can be good. You do have the rise of things like platform teams, because I think there was the increase the and it was really about this. The platform team arose to solve the problem I was describing of how do we provide standard solutions? How do we provide a golden path for people to follow? And when it's done right, then people do the right thing. And the differences can be, again, it's sort of like the email. Like there can be large changes of individual behavior from a subtle change of affordances. People I know, my favorite phrase was someone describing when they adopted continuous deployment, meaning every commit that would compile and pass the tests and go through all this chain of whole pipeline of things. If it passed all the checks, well, then it got promoted to production automatically with no human intervention.
Mm-hmm.
This is documented in Doing the Impossible 50 Times a Day by Timothy Fitz in like the late 2000s. People thought that was crazy, but people who did it, experienced it, said like, you know what it was like it sounds like it was changing from like having your work be on a slight uphill gradient to a slight downhill gradient. Right? It was a very small frictional change in friction, but a very large perceived effort. And so that's the kind of thing that I think where there has been a creation of a new discipline. You were saying a new area of expertise around, you can call it platform teams or development productivity or whatnot. And it's the people who are going to go ahead and provide that standard practice and the tooling to make the whole process seamless for their clients internally.
Yeah, so we were talking about this idea of the DevOps engineer, and I think a lot of people saw this coming who were early in DevOps, and presumably the same thing happens every time we go through one of these shifts. So we would have had like test automation engineers, and though we certainly have network automation engineers right now. I think there's kind of a through line here, which covers both like why that happens and why it's sometimes okay, so long as it's not forever. And also how technology spans chasms and gets adopted by people over time. So my experience is I was at TomTom in the late 2000s, and I was like, I guess it was like a round robin, but I ended up doing a lot. So I was the build guy on the team, right? I was actually a programmer, but I did the build a lot. And because of that, I learned how those things work, right? And I learned some kind of best practices, and like maybe you don't write your test like this, and here's how you should do asserts, and it'll go faster if you do X, right? So I built some of this kind of journeyman kind of knowledge, and then other teams had that problem. So I went from being the C++ guy that did the builds to being the build guy for many teams, right? And so you could say that I was helping with platform. Right, it's like a sort of underlying platform or a tooling layer. Now, if you move all the way to today, like at Netbox Labs, for example, I'm constantly dealing with the guys on GitHub. Like, there's no build guy, right? Like we set up the stuff in GitHub Actions, and it does it. So I think probably what we see is whenever a kind of new idea like this pops out, somebody in the company is either asked to or has a natural inclination to help more. And it creates this kind of build person, DevOps engineer kind of role, which is probably healthy in the short term. But ideally, it should be replaced with like sociotechnical systems / like practices over time, so that we don't, like you said, have dev and then DevOps and then ops, or like users and then network automation and then network people.
When you started doing that, did your title change? You know, differently, like, oh, now that you're helping people, we're going to change your title?
Not at first. No, certainly not when it was just like two teams. It was just kind of, hey, could you show me how to do that thing? And then it became official after a while. That lasted for maybe 18 months. Yeah.
Yeah. And the reason I ask is Chris Matz, who's a consultant in London and early Agile guy, wrote a really good book called Commitment. He has a phrase I really like, and he talks because he was looking at how the community and people in the Agile space changed over time between the early 2000s and late 2000s. And what he said is in the early days, what you had was a community of needs, right? The people were coming together and they're like, I have a problem. I'm trying to figure it out. I'm trying to find other people who also have my problem. And they were talking to each other and they were all figuring it out. So there's a community in London called XTC, the Extreme Tuesday Club. And that would be people would get together and, be like, hey, we tried this and it worked great. Or we tried that, but it's not working, or that thing I told you was great a month ago is no longer working. So it's a very dynamic time among people. And it's the kind of place where you were describing like the first couple teams. It's like you weren't creating titles to do it. You were just like trying to solve problems.
Mhm.
And then later, he says, later you come across with people who are a community of solutions, right? They're asking to say, tell us what to do. So the difference between the people who are inventing the things to solve their problems and people who are like, tell us what to do. And I think it's the people who say, tell us what to do, who say, oh, cool, this DevOps thing sounds great. We'll hire some DevOps engineers, right? We want to take the solution and we're hoping we can just apply the solution off the shelf to our environment. And that doesn't typically work. It lacks a form context fit, to use the Christopher Alexander term. Um, I think what happens is after some time, often the industry will come up with, okay, no, this is a better actual fit. So after many, many attempts at DevOps engineers or building or different things that people are trying to do, they realize, oh, here's a pattern that actually works, like platform team or like developer productivity. You might get called different things at different companies, but that's fine. But they've understood the patterns and then applied them within their context of their company around their problems. And so I think that's the kind of transition. You have things that are kind of informal, meeting the needs of the moment, to like terms that get a lot of airing and publicity. A lot of people pick it up, but maybe aren't always well thought out, like maybe more hopeful. It's kind of like the Gartner hype cycle, like, cool, DevOps is going to solve everything. We're going to hire these DevOps engineers, it'll all be great. And like, oh no, it's still terrible. But eventually you get that plateau of productivity as the knowledge and experience and context are all integrated. And then you get some like long-term value. It's because things really have changed just hugely over the decades, though it might be hard to see, minute by minute, year by year.
I want to talk about testing, but before we do that, I want to wrap up one thing around. I'm going to call it kind of. We talked about dones earlier,
Yeah.
and definition of dones. Actually, let's do it the other way around. We'll talk about testing first, and then we can close out with like introducing this to teams. So the thing about testing, and I'm a stickler for describing continuous integration tools as just things that run stuff and tell you if they work or not. Because
Yeah.
I think it's important that people understand that that's literally all they do. Now, sometimes they will do them in a certain workflow and they will do things and
Yeah.
have a whole stuff.
But kind of so what? You're doing them in the right. You're doing them in the right sequence.
Right. You're doing it in sequence, you're checking whether or not it worked, and you're telling the user, right? That's kind of
Yeah.
it. And for me, what that means is the link between continuous integration and testing is symbiotic. It's throughout. So even though, right at the beginning of your CI pipeline, you might have go and pull a bunch of information from Netbox. And that might fail, right? And that's fine,
Yeah.
because you can't do that.
Yeah,
You can't
that's
do the
right.
rest.
Yeah, yeah.
So in my mind, that would be an example of a test, even though really it's just expressed as a command.
There's a distinction I'll make here, which I find very generative. Like, it helps me think of new ways to approach problems. Michael Bolton, not the singer, the testing
That's a shame. That would
person.
have been a great coincidence.
Yeah, can you imagine? But no, but so the testing Michael Bolton, he makes a distinction about checking versus testing. He's like, testing is a human activity. Automated tests are really checks. And I really like that because it expands the set of things that we might think to check much more than if we think about tests. Because people usually think about tests as being about functionality, but you're checking like basic connectivity, like can we even talk to the thing in the running system, right? And that's the other distinction I'll make like about checking versus testing is it people think about testing as something before delivery, but checking can happen all the time. And since it's continuous integration, right? Where does it stop? Well, continuous sounds like it would keep going, right? All the way out to an in production, and I think checking as a mindset fits that much better to say, well, what can we check? What's the simplest thing we can check? What's the first thing we can check? Oh, can we even pull the configuration information?
Mhm.
Because every one of those things might fail. It's like, oh, you're like, oh yeah, we can check anything that could fail, we can check. Awesome.
That's a brilliant distinction, and I'm sure I've heard that before, but it had escaped me for a while. And it leads really nicely into this kind of topic I was moving towards, which is introducing this to teams.
Yeah.
And you know, early tens, I was working on this a lot and tried like a number of different ways. Typically, I was a consultant at the time, so I'd be hired to come and do continuous delivery, which is always not the best way to set these things up. And sometimes the teams are not on board, and you've been brought in because other people have tried and failed, etc. So it's like, how do you kind of find the gap in the gate, right, to get in there and start making things happen? And what I found was this wonderful thing that people either understand or they can understand quite easily if they don't yet, which is the definition of done.
Yeah.
Which is like at the end of our process, whether it's a month or 2 weeks or whatever it is, like how do we know we're done? And
Yeah.
typically, and this definitely happens in the network engineering world, they will have a bunch of checklists. And some of those checklists have arrived from the comfort blankets of other teams earlier. That's right. Like we need to have done all of these things in order to say that, this is safe, right? Whether or not that's
Yeah.
true. And I found that to be a wonderful way to start helping people understand, well, maybe we could take one of those 40 things, and this time round, we're going to check it
Yeah.
automatically and see if that helps. And then next time, we're going to do two. And this is a very intuitive process, which doesn't include words like automation or anything else. It's just like, do you like doing those things? Not really. Would you prefer a computer to do it? Great. And then
Yeah.
if you do those for long enough, you find that you've moved the reasonable kind of distance towards a lot of the supposed goals of all of these movements in the first place. Is that
Yeah.
kind of something you've come across, like introducing this to teams in a way that's stomachable?
100%. I mean, even so, there's a couple of things that come to mind from it, stories in the past. I mentioned earlier the Timothy Fitz. So Timothy Fitz was at a company called IMView, which some people might recognize as the company that spawned the book Lean Startup. Eric Ries, when he wrote it, he was talking about his experience at IMView. Anyway, in this article, they talk about all the things in their cluster immune system that allow them to deploy automatically, safely, 50 times a day. But one of the key elements of that story was they started with a process that was entirely manual, right? Everything about it was manual. And then what they did is every time they did it, they automated one piece of it. And to me, that's very analogous of your story of like, we have this checklist that we kind of don't like checking. Can we do it? Can we automate it? And that was also very, very much my motivation early on in CI, where the in the late 90s, when you went to QA and you had test scripts, the test scripts were not they were step-by-step instructions that were automated by a person, right? A person executed. They said, okay, go get the software, open it up, follow these 10 steps exactly, and your job was to be a robot, right? And here's the thing about that is that humans are actually really shitty robots. Like we're just really bad at doing the same thing the same way every single time. That's just humans just are not good at that. Like, and this Alistair Coburn, another Agile Manifesto signatory, he wrote a paper called People Considered First Order Nonlinear Components of Software Development. And I love the title, very non-humanistic sounding, but really humanistic in intent, which is it basically says people matter, right? That's what it says. And what he says is because people matter on software projects, we should study them. We should understand the properties of people. We should understand their strengths and weaknesses, and we should play to them. And one of the weaknesses he points out is that people are incapable of doing the same thing the same way every single time. So if you want something, if you have a checklist of 40 things and you want those 40 things checked the same way every single time, that's a job for a machine. That's not a good job for a person. It's just people are not good at that. But, and this ties back to what I said earlier, but the number one attribute of people on projects is that people care. They want the project to succeed. And he's very direct, and my experience matches that no project ever succeeds except that people on the project want it to succeed. It is discretionary effort put in by people that make projects succeed. And the connection between these two then is, cool, how can we leverage the machines to check these things? And then once the people have the information of a failing check, they will care and they will act to solve the problem. And so the process you're describing of the win-win between, cool, we're going to take off this job you don't like doing anyway, and you're bad at it, under my voice, and you're bad at it. We'll go ahead and automate it, and now you won't need to do it. But when the system tells you that it's not working, you're going to just instinctively care and fix it. Like, no one will need to tell you. No one will need to say, once you know it's broken, people are going to be like, "Oh, darn, that's broken. We should fix that," Because
Yeah.
and there's something we said earlier about having a shared sense of truth, a shared source of truth that you can look at and say, "Is this what you had in mind?" Because as we're saying it now, like go back to the properties of humans. Humans are bad at realizing that their model is one interpretation of the facts, or their interpretation is, it's just one model among many, and everyone on their team has their own view of reality. There's this is a fallacy called naive realism. Naive realism says, I look at the world, I see exactly what it is, and other people say the same thing. That comes up in everywhere in all human activities, but in the case of network engineering, people will have a conversation about what they're going to do. What are the changes we need to make on the network? They will have different interpretations. They might even, if they're really, really good and disciplined, they will have a note that says some English phrase about what the change is. And then people will have entirely different understanding of what that means in production. And if you don't go and generate a place where you say, this is the shared fact of what exactly is going to change, those differences will go uncaught until there's a problem. And this is not unique to networking. This is true for all human endeavor. I love the story of a airplane delivery where the two different parties have a different idea what it meant to deliver the plane. In one, it was like ready for testing, and the other one, it meant tested. Very, very, very different methods. So this always happens with humans. And so I wanted to just go back to that point and underscore it, because it is, again, it's about understanding the properties of humans and having our socio-technical systems give us practices that emphasize the strengths and offset the weaknesses. So
Let me tie that back to what I started saying, which is about this. If it hurts, do it more often.
Yeah.
Like that. You're like, oh, that's kind of fun. Yeah, that makes sense. We should do that. But just hidden, just like a couple of centimeters under that is like, we're going to do something that hurts more often. And that might not be very, very pleasurable. I think where we arrived earlier is that using something like a shared definition of done, or taking checklists that people have and maybe starting small, is one way to get teams through doing painful things more often. Another way we touched on is you must find yourself in a situation where people in the team actually want the project to succeed. Otherwise, you're really starting from nowhere. Is there anything else you can share around? There are a lot of people going through this network automation shift right now. They're probably having a frustrating and difficult time bringing people along for the ride in some cases. What have you seen?
Yeah, well, I think that's a good point that, like, it seems like, telling people to take the thing that they find most difficult and say, well, cool, we're going to spend way more time in that world. Doesn't sound appealing. But there is an offset there, which is part of what makes things difficult is the passage of time. Um, so what made integration so perilous and deadly in the 90s was that you were dealing with inventory of 9, 12, 18 months to 2 years and trying to handle everything that had built up in that period. When you say like, oh, we're doing our second integration of today or this hour, right? The units you're dealing with are very small, and it turns out that the level of effort and complexity is very nonlinear. So it's even if we're just the linear sum of work, which it is totally not, even if it's just the linear sum, the fact I'm doing it in small pieces makes it, less of a problem. But because the complexity is much more than linear, the total time savings are much less. And so every problem is easier, goes faster, and it becomes like not as difficult and not as painful. And then you say, well, what can we do to make it even less painful? In my experience is that when people start to get the virtuous feedback, then they start to feel better. But one of the things to get people there is that goes back to like, why are we doing this? And when I would go in and try to talk to teams around adopting continuous integration or continuous delivery or unit testing or pairing or any of these things, I didn't start by saying like, here's what's going to be great about it. Here's how it's going to be fantastic. Just shut up and go along with it. Instead, I would ask them about like, well, what are the problems that they have? It says like, do you have bugs? And they would say, yeah. But then I would use what I called the 5 so whats. So what? So you have bugs. And they'd be like, well, that means we can't ship the software. I'm like, so what? And try to draw them in it, try to pull out for them individually, uniquely, like how did they experience the pain? And I had some things that really stuck with me. I remember someone saying like, I want to be able to, go home on Friday night. I want to be able to enjoy my weekend without the pager going off, right? So their motivation for making the investment to change the way they're working wasn't, oh, this will be cheaper if we solve it later, or, will be better, but like, I'll be able to not have my weekend with my kids interrupted. And that's what gave them the motivation to say, cool, well, I have something that might work. It's worked other places. Would it be worth trying the experiment? And that's the thing is I would say like, we're going to try it. Probably we'll need, if it may not work here. I don't know enough of your conditions. Maybe it won't. But why don't we, is it worth trying the experiment and with the hope that you would not work overtime every week, that you would not have to stay late, that you would not be getting the pages. And that's where that was the motivation that allowed people to make the investment to try the experiment. And then the experiments either worked or didn't. But I will say this, I never found a place where people really tried that didn't work. What we did have, and this is actually very important, is I would talk to people and it was consistent. They would say, ultimately there'd be someone who was very skeptical. And I'd say, well, why is that? And they're like, Jeff, what you're saying sounds great. And it really makes a lot of sense. And I agreed, in principle, it's even the right thing to do. But the business won't let us do it. The business will not allow us to make this investment, right? You're asking us to spend this more time on this or that. And, we don't know how to do it. There's going to be learning overhead. And sure, it sounds good today, but in a couple of weeks, the business will be saying, you know what, go back to the way you're doing things because we don't have time. We're under pressure. Now, when that would happen, now understand what's saying here. What people are saying implicitly is, I want to do the right thing by the company. And even if I think this is the right thing, if the company doesn't want it, then I can't do it. So the solution for this is to, and I would say to people, is go and find someone ideally on the business side, not technology leadership, but business side, as high in the org as you can, to come and talk to people and say, look, I understand that we're asking you to work things a different way, and it's going to be slower and awkward because you're not used to it. Um, but we in the business, we want that. Here are the benefits and payoffs for us as a business. We think it's worth doing, and so we want to do the experiment, and we're willing to pay the price. And in organizations, I would get one of two answers. I'd either be like, right, that makes sense. Let me go get, no problem. I can go get the managing director. I can get the CEO, right? And the CEO would come in and say this, and people are like, right, I guess we're doing it. Or you had the other kind of organization. We went once to the technology manager and we said, look, the teams are worried that they're going to do this in a couple of weeks. The business is going to say, just stop doing that, go back to what you're doing. And he goes, yeah, they're probably right. I was like, cool. Sounds like we're done here. Like there's no, I'm not going to, I'm not going to go spend time trying to train these people on this stuff. If you just think you're going to give it up, we should just call a halt right now. So there is that challenge to the company and the technology leadership to say, like, are you clear enough? Is this enough of a problem? Are you clear enough what the problem is to the company? Can you translate it to the business about why they should care? And do they then say, yeah, you know what? Mark was right. Finding problems later costs us more money. We'd rather find them earlier. Money is like a proxy for however you does it. It's either time or opportunity cost or whatever it is. It could even be literal, like we have to pay people back from our SLAs being violated. But the company realizes that delay between problem introduction and problem discovery is worth making the investment in. As soon as you have that business buy-in and that alignment, again, because people want the project to succeed, they want the company to succeed, then I think you overcome the resistance people have to learning, and which means going out of their comfort zone, taking more time, feeling awkward. They're doing that if they understand what the payoff is, and they understand this is an experiment that you're going to say then, like, is it working, and adjust if it's not.
There's an organization called the Network Automation Forum that we're big friends with, and they have a great mission statement, which is phrased as a question, which is, why aren't networks automated yet? And as part of that, they run surveys. And I don't think I saw the last one, but it's like twice a year, I believe. And on their survey, at the top of the, why aren't you automating more of your networks questionnaire, and I'm sure I've seen this in many other places. Number one is cannot get permission from management or something like that, right? It comes up all the time. It's hardly ever. I mean, there's certainly skill gaps. I think that's another one. But yeah, number one, very often is we can't get permission to run these experiments, to even try to learn how we could make this better.
Yeah. Yeah. No, which is interesting. I do think there is an element here of how you introduce it, because sometimes partially it's the way people ask is they're like, we want to do this very disruptive thing of totally changing the way we do all of our network design, and it's going to take a long time, and we're going to do a lot of training and blah, blah, blah. And so will you sign off on this, very expensive change process? And the executives are like, no.
Yeah.
Why?
Seems like a lot of unmitigated risk.
Exactly. Why do you want to do it? And literally I'll have technologists tell me, they say, like, well, because that's the way the industry is moving. And so, like, what? So you basically, well, this is what everyone wants to do, right? They haven't put it in business terms why it would matter on the one hand, and second, they haven't talked about doing this in form of small, safe-to-fail experiments, right? Go think about what you said. Do we have permission to go? We have this item on our checklist of 40 items. We're still going to do it, but we're going to try automating it. It might take us a short amount of time to automate it, but we think it'll then be better. Yeah. Then in that case, you get questions like, of course, why are you bringing it to me? You're expected to do this, to do your job and do it better.
When you start small enough, often the question is more like, we've done the first 20, we didn't tell you that, and it's been really successful. The next 5 are going to be a bit harder. Can we talk about that? Yeah.
Yeah. And here's the benefits we got from it, and not telling them about the first 20. I say, like, there is an element here of like what your motivation is. I really think it's worthwhile checking your motivations. Sometimes people are doing like, yeah, we don't want to tell them we're doing it, but there's sometimes where things are so frictional. You'd say like, well, if it's going to take you half a day to do it, like it's probably not, that doesn't rise to the point that the exec or whatever, their meeting with you for them to say yes costs the company more than you
Then
trying and
trying.
failing in that half day, right?
Yeah.
So that there's an element there as well. But we get into like complex interplays of psychology now between autonomy and psychological safety and internal communications and information flow. And those are great topics that we could spend 5 hours on, but maybe a little bit further from the direct point.
We definitely could. We're going to wrap it up here because we have a sort of a time limit for these things typically, but I think we should definitely come back and talk about some of those other things because they're arguably even more critical than the level that we've been at today. Jeff, I want to say thank you. Before I say goodbye, though, where can people find you and your work? CITCON's coming up. There's a book. There's a website. There's a podcast. Could you share some places
And
for people to look?
yeah, I think agileconversations.com is a place where you can both find links to our book, and also that's also the home of the Troubleshooting Agile podcast. You'll find it there, and a link to our, at this point, many-year history. I can't believe I'm not even sure what number of podcasts we're on. Maybe somewhere in the 400s, and many episodes. And we love to get listeners writing to us, so you can do it there. I'm also on LinkedIn. And yeah, I would love to hear some of your listeners, if anyone who's around the quote unquote London area of Woking, to join us on September 26th and 27th for CITCON, a free open space conference about how we can make software development better, including the networking side of things. So it'd be great to have some people there talking about that.
All right. Thanks again, Jeff. That was great.
All right. Thanks, Mark.